During the first 2 days, whenever someone asks me, hey, what is your topic? And when I say stability of the UI test, everyone just thinking that I'm going to talk about the failures and the flakiness of it. But the thing is, we had a really great winter last year in the company, and we were able to focus on lots of flakiness and lots of things. And we now have 800 tests, UI tests, for Immobile and Squad application. And those tests, at the moment, run and report the results under 20 minutes. And that's a duration sometimes faster than the unit test execution, thanks to the whole parallelization and all optimization. So that also allowed us to integrate our UI test pipeline into our PR build pipeline. So that means we are able to run all of those tests with every commit and every change. And what other good feature that we kind of was able to integrate is having UI test per feature modules. And what it means, like we have more than 150 modules at the moment, and 18 of them I have one way or another a UI test. So whenever we start a new feature, we are able to provide necessary behavior test or end-to-end test for that feature without any problem. And that doesn't mean that we fully rely on UI tests, because I don't suggest to anyone to fully rely on UI tests, because it's still not fun experience to learn locally. It might require long run time to run on the CI as well, but you still need to depend on the unit test. And having this balance will also help you to have less flakiness. But let's also first start with what is Android test. So one aspect of the Android test I would like to focus on, we focused on, and I would like to give an explanation to, is the user interface test. And how we can do the user interface test with the actual human beings, with the QA team. But if we have a human in between our application and test, it will be time-consuming, tedious, and error-prone. I know from myself, as I develop an application, a feature, even though I develop it, it's possible that I missed a bug and I missed to press a button or check additional features that we already had. But what we'd like to have a good developer having automated test, and that should help us to run our tests quickly, have verification for the user interaction, and we should be able to run them whenever we would like to have. So we shouldn't depend on anything. And how it happens, we can start writing our test in the Android test folder, and with a couple of necessary setup in the Gradle, Android Gradle plugin will create a new test APK that you can run on the device. And with that APK, like with that test, you will be able to test your logics and the application on the device itself. But why do we need the device in the first place? With the unit test, you can cover business logics and other kind of logic that you have in the application. But if you want to cover or check the UI interactions, end-to-end features, or would like to check the flow if you have a certain requirement from your product, if you like to check those kind of things, unit test will not be enough to cover the full picture. And you can still have failure even if all of your unit tests are passing. And the other reason is you might depend on the device resources like location, sensor, or camera. In those cases, you definitely need a device. And if your code doesn't have any Android SDK usage, like URI, intent, and if you are able to decouple your code from the Android classes itself, that's great. You can write a logic with the pure Java or Kotlin, and you can create unit tests with it, for it. And that means that you can run your test on your local device without starting an emulator or device. And that will help you to utilize your time and resources. And that's the reason why we have so many architectures. Because the main idea is if we decouple from the view, which we cannot directly test on the GVM, and put the logic in some other place. It could be a view model, it could be presenter, controller, whatever you like. The main idea is like separating it so we can have reusable, testable stuff. But let's say you have an Android SDK usage, and that happens when you start interacting with the views and the screens itself. That means you won't be able to run them on Java runtime without any special support. I know there's like RoboElectric library, but for keeping this talk, I would like to just focus on, I would like to act like there is no such a thing called RoboElectric, if that's possible. So I will continue with the Android test on the real devices. And when you have those kind of Android SDK usage, you definitely need Android runtime because those classes will be only available on the Android runtime. Or we can say, well, if we use the stability, will there be, if we use the real device, will there be any stability? I can say no. And you all Android developers, you already know that there are thousands of different Android devices. And even if we write the simplest code, hello world, it's not going to be stable on the real environment. So how we can write a stable test on the device itself? But let's focus on the problem, because the thing is, if we start focusing on the problem one by one, there's a possibility we can fix those. And the big major problem is the device issues. We don't have any control over the device that we are running the test, because our test will be an APK. And that's going to be an application. It will be same as the application, but with the help of the So that means if there will be any notification, as a developer, you need to handle it, or you need to prevent that emulator or device to show the notification, or you don't have any control over which kind of keyboard they have. You don't have any control over which kind of pop-up they might show if they have 3G or 4G. It's not a good environment. And if you have a big team already, everyone can have different screen sizes. One might like a small device, and the other one might test on tablet, and that will also create consistency problem. But the other big issue and the elephant in the room is the asynchronous issues. And Android tests definitely are not aware of your classes, because the whole goal of Android test is focus on how you can test it. But as a developer, we would like to focus on what we can test. And this is a basic example of what might look like while we're running on the test, while we're running test on the device. So the test itself will have a test thread that will contain our assertions, checks, or UI edits. But the application will definitely not run on the test. The application will run on the device with its own main thread, and it will continue to render and the loop as normal application. So during this test execution, our test thread will go and check the application itself, try to find something there, do assertion, change some property, and return back to the test thread and continue. But during this execution, if one of our checks depend on a result of a background operation, that will be the first source of the flakiness, because that background operation is something we might not be able to control how long it's going to take. If it's the I/O operation, for example, on some devices with the new RAM technologies and with the new storage technology, it might be fast, but for the majority of the part, we actually don't have any control, so we cannot do any assumptions. And in those cases, it will be flaky. But the good thing is, there are APIs for it. So Espresso is a library started by community, then acquired by Google in 2013, and now it's part of the Google, and they keep releasing new versions supporting the Android ecosystem. It has API to write Android tests. Don't even use your own class implementation, or don't care about which kind of architecture you have, but just focus on application and tests from the user perspective. There are good integration of Espresso. First of all, it is aware of the main thread. So it checks the message queue of the main thread. And if there is something waiting to be executed, Espresso says that I'm not going to do anything until the main thread will have the free message queue, because that will show that we requested something on the main thread, but device was not able to finish it, and it still continued doing it. And Espresso also aware of our good friend asynchronous task. Why it's important? Because it's part of, why it's possible? Because it's part of the operating system itself. It is part of the runtime. So when Espresso runs on the device, it's aware of the async task and able to track it. And the one other low-level API that Espresso provides to us, defining custom idling resources. And we will come to the topic much detail in this code, because this is the part that we can create our solution and get rid of the flakiness. But before going that, I keep saying that Espresso is the low-level API. And Espresso focus on how to find views, how to assert actions, or how to perform an action on the screen. But as a developer, as a product owner, or as anything like that, anyone who would like to write test, you would like to focus on what to test. How to test is an implementation detail, and it can change. And as a developer, I really don't want to focus on how to do it. And as you see, the robot can go inside to a door, but if you look at it from the test perspective, it is successful. And all the assertions are passed, like it was able to hold the handle as well. And with the robot pattern, the suggestion is having a class that knows all the details of the Espresso, like how to find the view, how to assert, and creating small methods that will be reusable for the different part of application. In this example, if you say that our robot will have a method saying that hold the handle, and the second method is the push the door, and the third one is the go forward. And what we are missing, like we might have a problem in our Espresso robot saying that it didn't push enough. But that's the idea. And when we write test, it should look like this, because we expect to have we would like to see what we need to test. And if you look at from the to-do application example, we can say that we would like to launch a screen, assert the list, update the text view, do some actions, but none of them actually about how to do it, and how to do it should be hidden from some other place. And there's a really great talk from the Jake Wharton, and I think he's the first one who suggested using robot pattern for an Android UI test, or it could be, or like anyone who publicly speak about it. And we keep using this approach, and that helps us a lot, because even if your UI change, most of the time your use case is still same. Your button change, text can change, or position can change, but the expectation, what's going to happen when you press that button, will probably stay same. So you don't need to changing hundreds of tests that you have for that screen. So far I mentioned a bunch of other stuff, and I can already imagine that some people thinking that, hey, there's a learning curve, like Espresso APIs, we already read the documentation. It's not easy to remember all of the stuff. And there are different problems with the learning curve as well. The first one is the Espresso APIs. They're good. I don't say anything bad about them, but for me, they're not intuitive. Time to time, I cannot think around those APIs. I cannot find the correct usage. And there is also another problem, that initial setup of a module. And we might need a custom dependency injection. We need to set up our stubs. There might be a duplicate code just because we would like to change some stubs and everything. And whenever you create a new module, there might be different setups that create different best practices depending on the person or like implementation. And those are also really big learning curves. And that can create boundaries to reach the first test. And we had that one. Like we spent like weeks to reach the first test, and we had 20 tests in the next couple of days. And that already showed that how hard, like how difficult the problem it is. And like I said, there are random failures. But what I would like to focus and consider, there's no such a thing random. We just need to find out the root cause. It can fail just because device has died, but the reason will be that probably device has died. Like, so you cannot just blame Espresso or Android device or the test for this one. And the other problems is that Espresso test will take some time to run because they are going to render on the device. So if you have a performant application, that means your test will be performant. So if you have a application with lots of frozen frame, you're going to have a long time. And not running UI test is also a challenge if you're running your UI test once per week, once per month. That means the time that you detected the failure is not the time that you introduced that failure, and that will create disconnection in the pipeline and create problems to fix about that one, and people will not hesitate to ignore. And let's start how we can simplify that learning curve. We talk about the robot pattern in Espresso, right? And there's a helper library called Kakao, and the only purpose is creating readable, reusable APIs, robots, and screens with extensible Kotlin DSL. It's like 100% Kotlin, and the goal is to help you not to test, not to change the behavior of Espresso, not to change behavior of any test or anything. It also doesn't come with any magical power. What it does, it's just a wrapper and creates high-level classes that you can use without, you don't need, so it helps you to not deep dive in the Espresso, but creates high-level implementation. And the example is, one good thing is about the Kakao, it enforced the robot pattern. It asks you to create a screen class, and instead of saying robot, it's called screen. What you can do in the screen class, you can do whatever you like you can create methods and whatever kind of stuff. But the good part of Kakao is like, if you need to test edit text, you can create a K edit text. And with the K edit text, defining the view and doing the operation will look similar to Espresso APIs. So if you already know or learn the Espresso, or like if you need to do a Google search, it will be similar. But in this example, we need to find the K edit text and the K button. And you probably already guessed, there are a bunch of other view elements like K view pager, K recycle view. So it's become intuitive to find what you need to write in your test. And when you start writing a test, those types automatically come with some default implementation. Edit text has edit text has text method that automatically find the edit text and checks the necessary views. Or there are like default performable actions like click or check focus or other stuff. So when you start writing your test, it looks like this, and when you read it, it will be much more readable. And in your robot, you actually don't have any implementation detail. So you actually can delegate all of half the test part to Kakao itself and just focus on what you would like to test. This helps us to speed up our process of writing tests, because once you start having a screen like this, writing a new test just become writing an English sentence that you can also understand. But let's talk about other bad habit that we might have using thread slip. And thread slip is never a solution. Just having a green test with the thread slip is not going to change anything about it. You're just hiding stuff, and don't let anyone to use thread slip in anywhere in the code. Like, there are edge cases you might need to have, but for the I work in the industry, like I've worked, or write lots of code. I had never a time that I really need the thread slip. So probably 99% of you shouldn't need to use. And if your test pass when you add the thread slip, that's the clue you need. That means you have concurrent code. That means that your application does something in the background, and you need to find it out, and you just need to cover it. Other thing that can affect the stability of a UI test is animation. And I can with the cool animation, but the thing is, all of you might expect where was the text. So this is how Espresso actually works. It expects the text to be there, but if you have animation, so it's going to fail. And let's say, let's talk about the animation. Like why it's a worst enemy of the Android test, because there are millions of different APIs, and every new day, Google keep introducing something new. And with the Compose, for example, we are going to have a bunch of 20 or 30 of other animation APIs, and none of them use the same architecture or the same resources as the other. And we can get rid of the animations most of the animation just by a Gradle property. This will tell the device to don't do any window animation, don't do any transition animation, but eventually it will try to stop all that animation. Bad thing is there might be some views that you're using is not aware of this kind of solution. So in those cases, you definitely need to go to that class or like implementation and tell you need to stop. And one example is like loading indicator. Loading indicator doesn't care because it actually doesn't do any animation, but it's just in the loop. And if you even cancel the animation, the loading indicator will spin. And if you like to do screenshot testing or something like that, it will be flaky. But there's like reflection-based hacks around it to stop and chill down. The important part, what you can do, is using Espresso idling resources. And this is an API lets you to define a resource. And in that resource, you can tell Espresso that you are busy or not. Espresso will keep asking questions, we'll keep calling those resources whenever Espresso wants to run something. And if all of the idling resources are busy, Espresso is not going to do anything. And those are the kind of operations that you might want to create idling resources, because those kind of operations will take time, and you definitely need to execute them. Please execute them in the background. And you definitely need to want to execute them in the background. And if you are loading a network data, we should let the Espresso know about it. Otherwise, it's not going to check anything and continue to run and will be flaky. And I highly suggest that don't change the production code just to make your test pass or just to make your idling resources possible to register. What you can do, you can create listeners, you can expose the life cycle of that component. I'm not talking about just the activity life cycle, but like if you have a background operation, you can create a listener that tells the status of it. I started, I finished, then your idling resource can follow up those kind of information. But please do not register any idling resource in the production code. And one of the best practices, creating JUnit test rules to register and unregister idling resources. With that approach, you will have reusable JUnit test rules that you can create. You can reuse in the different kind of application, different kind of test. But what we can talk, and I already mentioned that, asynchronous task. Our good old friends deprecated, dying. But the good thing is Espresso check asynchronous task. Why it's a good thing? Because there might be an operating system code or like SDK code that use asynchronous task, or you might have a library with the asynchronous task usage. In those cases, you don't need to do anything, but that's not a suggestion to use asynchronous task. It's still deprecated. Go with the better solutions. And asynchronous task, the only concurrency solution that comes out of shelf, like out of box solution, because it's part of the operating system. So the time when Espresso was written, they had opportunity to go and check the Espresso. But other options, like RxJava or coroutine, will not have the same behavior. But after the asynchronous tasks, the suggested way of executing stuff in the background was thread executors and the thread pools. And that could be the easiest solution to use. Libraries use a lot because they don't want to depend coroutine or they don't want to depend RxJava, and they just create their own thread executor. And one good thing is you can have a single place, an injection, or a static class. Like I don't suggest it, but you can have a single place to provide all of those executors to different part of your application. There are different libraries or frameworks that ask for thread pools, or you can swap them. And if you don't swap them, every one of them will create their own thread pool, and that also affects the performance of your application, which is not good. But the important thing, you need to be able to swap thread pool executor. And there's also an unreleased GitHub sample from architecture component, and they already have a counting app executor rule, and they're already using this app executor pool and the provider approach there. But the reason why they cannot release it, because Jetpack libraries, and not the Jetpack libraries, but architecture component libraries doesn't depend on the Espresso, so they cannot directly give out-of-box solution, but they can give those kind of things on GitHub and hide it. So this is a class which didn't change like 2 years, and whoever I ask, like no one knows about it. And their tests keep passing, by the way. Like they don't have any problem, so they also probably don't see the pain that we have. You might still have RxJava in your code base, and if you have, good news, you're lucky. There's a library called RxIdler, and it provides default idling resource implementation, and you can directly register it like this at the beginning of your test, and it will let Espresso know that there is a background task going on. It is a game from Jake Wharton, I guess. Like probably he had lots of headaches back in time. But that's a good approach. If you just have the RxJava and doing background operation, you probably won't going to need to register any other idling resource, because RxJava will handle all of it. But as a community, we didn't stop there. We moved on Kotlin and coroutine. And interesting thing, there is no such a thing at the moment. So there is an open issue with lots of suggestions from the community with the reflection and other kind of stuff, but none of them are clean enough to remove all the flakiness from their application. One solution might be that if they let us to change the default dispatcher, we can put our own dispatcher there during the test. Then it's a possibility to write an idling resource. But until then, we cannot do anything. Even if we use the same approach as the thread executor and create our own provider and swap dispatchers during the test, it's not going to affect the libraries. And for example, retrofit will continue to use dispatcher.io, and it doesn't have any direct way to change those dispatchers at the moment. So all of the libraries that you're using needs to support it, and no other code should use the default dispatcher, but always use your provided dispatcher. So it's not possible at the moment. And if you just start coroutines and writing UI tests, you will directly get flakiness. And those are the operations that we might need an application. So if we cannot provide a solution for the framework we are using, what we can do, we can go unit by unit and provide solution for them. And let's go over an example. Let's say that we have a 2D application, and in that 2D application, we would like to fetch a data from network with coroutine. We have a live data to update from the background, and it was a best practice 1 year ago, like, or something much earlier. Like, let's say you also have data binding, you have this pleasure to work with data binding, and data binding will set everything to recycle view list adapter. What could go wrong? It's all best practices from the Google, created by Google, supported by them for certain, a little bit, not too much. And good thing is we can write an idling resource for the OKHTTP. We can create an interceptor with an idling resource that follows all of the network operations and tell Espresso to, hey, I'm busy or not. And what I suggest is don't ever rely on the real backend data for the Espresso test. It will be flaky by design. The best practice is using JSON data to represent to network responses based on your test use case. I don't suggest you reuse the same JSON. Just create new one. Just create a specific one. And even if you have JSON files and read them, it's going to take time. There will be an IO operation. So you are still going to need this idling resources for the OKHTTP. And my suggestion is if you need to swap, if you need to stop the network operation, you can use mock web server or mock retrofit. And just play with them and decide which one you would like to use because they have different different way of handling stuff. But we pass the data to live data. What could go wrong? It's a long, everyone's favorite class. And let's say we pass the data with the post value method. But the post value actually use architecture task executor. That's a kind of wrapper that I mentioned earlier. So architecture component has its own thread executor pool that it creates for architecture component elements like live data, room, or other kind of stuff. So whenever there needs to be a background operation, they automatically use this one. But the good news is there is a delegation. It supports delegation, so that means we can also pass our own delegation. And it also comes with counting task executor rule in the testing package. That's good. That means we can swap the architecture task executor with the counting version of it. But as you notice that it's not idling resource, it's just counting task executor. The reason is that architecture component doesn't depend on Espresso. So as a developer, we need to bind that information and create an idling resource for that counting task executor and let the Espresso know that live data might wait for some operation. And this was an interesting one. This was we hit this one a lot. And the moment we understand that it's like this, I got sad because everyone keeps saying that live data is the future and that we should use it. It was like 1 year ago. We pass the data binding reactively follows the value, and now data binding is going to update the UI. So what could go wrong? If you don't know data binding, it's an XML-based solution. The compiler automatically creates the updater class that handles the view operations, and you can pass a direct value or the live data, and depending on what's going on, data binding execute operations. But the thing is, data binding will not execute your data changes immediately. It will wait for the first possible frame to update the UI because it doesn't want to create any lag or freeze on the screen. So it will wait for the next frame. And there is no executor to swap, right? Because you're setting something on main thread, and it's waiting on the main thread. And with the listener of the next frame, it's going to update the screen. And there is also data binding idling resources in the architecture component, which is, again, hidden. No one knows about it. No one suggests it. Any documentation doesn't mention about it. But it is for the basic use cases. If you have a data binding in activity, it's going to work. But let's say you have an advanced use case, it's not going to work. You can have data binding in fragment. You can have data binding in a view folder of a recycle view. That means what you need to do, you need an advanced version of data binding idling resource, which finds all of the views in the screen, try to understand if they have data binding, and ask them, hey, do you have any pending binding? And if at least one of them say that, that means you still need to wait for, the Espresso needs to still wait for data binding to finish updating the screen. So we just need to make sure that every one of those happy. But again, we can handle all of those until now, and we pass the data to recycle with list adapter. And by default, list adapter forces us to use diffutil, and it creates a thread executor itself to execute those diffutil stuff in the background. But the good news is it also let us to change the thread executor while we're passing the diffutil. So it's also a secondary constructor that you need to use, but none of the documentation or the best practice mention about it. That's also really sad. But if you already have an application-wide thread provider solution that you are able to swap, that means you can use the same thread to pass the same executor to list adapter and ask list adapter to use your own thread executor, and while doing a test, you can swap it. But by default, if you are using recycle, even if you disable animation or anything, list adapter is going to be flaky. It probably will work on your device because your device is fast. When you put it in an emulator or cloud or some other place, those background operations, when they start using real GPUs, like with the visualization and other stuff, they will take some time to finish, and you will hit the flakiness. And I mentioned a bunch of interesting solutions. I suggest you to create a module that can have all of those solutions in one place. And what you should do is create reusable solution units. So whenever you have data binding, just use that rule. Whenever you have live data, just use that counting idling resource rule. But don't try to create anything that try to fix everything, because it's going to slow your test down, and it's not going to be clear for your developers to what you are actually fixing it. So teach people in your team that what kind of edge cases there might be, and teach them to understand what they're actually developing, because I didn't know that live data works like that, and I felt like it works magically under the hood, but like, we should always know and understand what kind of technology that we are using. And let's say we get rid of all of the flakiness, but one thing that we are not able to do is, like, if you are only running on your local device, that's a problem, because everyone will going to have different device. What you need to do is pushing this responsibility to collect as much as you can. And we are using Firebase Test Lab because it was there from the first day, but there are different vendors that you can use. But the important thing is that you can prefer some vendor with a cloud-based device form. And the important thing, they should have optimized device. What that means, for example, Firebase makes sure that there's a necessary wake log for the devices so they don't go sleep while you are executing tests. They don't let the keyboard to pop up. So they kind of manipulate the operating system with their root access and handles all of those kind of things for you. And they have real and virtual devices, and the virtual devices are much cheaper. And you're not going to wait any queue, but if you use a real device, there might be queue. So choose your vendor depending on that one. And the other good feature those device forms can give you sharding option. And the sharding means that creating test matrices to be able to run them parallelly on different devices. And that means if you can create balanced test matrices, you can immensely parallelize your test execution time, rather than waiting for 1 hour. If you say that you have 60 shards, that you are going to wait 1 minute. And that's the case really well. And the Firebase supports it. But for Firebase to support it, you need to use some experimental flags, custom stuff. And no one likes to, like this, I don't like to deal with command line parameter in the Gradle, so we can call a command line tool. But for that one, there's a really great library called Flank, and the only purpose is massively parallelizing Firebase tasks smartly. And what it does, it records the current test results in the Google Cloud, and during the next execution, use the same result from the previous one, test execution times. From those test execution time, create equal duration matrices and run those matrices on Firebase. That we can define how long a shard should run. We can define timeouts. That means that if you like to expect your UI test to finish in 3 minutes on the Firebase, you can kind of have it. But you just need to keep in mind there will be time for initialization and the device setup. But like I say, it's a command line tool. For that one, there's a Fladdle by Nelson. I think he's there. And I would like to thank you to him for this cool DSL, a Gradle DSL API, because it creates the YAML file for the Frank, and we can configure all of those complicated stuff in the Gradle, where we actually know as Android developer. But when you want to have multi-module test, things are getting interesting, because then you need to give, first of all, why we would like to have the multi-module test, because the test will be in the isolation. It will force you to reduce the coupling of the features and force you to have foundation modules, so you can have less problems while developing. It will help you to have having faster build times, because when the features stop depending on each other, when you change one feature, you are probably going to compile 1 or 2 modules, and it will result in developer productivity. And if you don't, while you're testing, if you don't have the other features code in your test APK, that will create less flakiness and less opportunity to fail. But the cons, maintaining configuration is error-prone. And Fladdle, you need to pass the path of your module and your test APK if you have a different module. And it's error-prone. We also had this one. People added new modules with UI test, but they forgot to update the Fladdle configuration, so their test didn't run on the CI, and when we noticed they are not running, it was too late. And from those kind of conversation, I think the Fladdle born, and like Fladdle helps you to, like it's a high-level plugin by Fladdle, and automatically finds all of Android tests and set intelligently to the YAML file and talk to the Flang. And with that one, you will have a full optimization of the Firebase pipeline after you set up the first thing. So for last 1 year or something like that, we kind of didn't change anything in our Fladdle configuration, just updated a bunch of other stuff, but that was the kind of only thing that continued to work without any maintenance. And the future. So at the moment, we have a pipeline. Whenever someone pushes something to the GitHub, our UI test runs, and we don't let anyone to merge any code when they have a failing test. But what we can expect, there's a good initiative coming up, emulator snapshot for failed test cases. That means you will be able to run the emulator from the place at time and when it failed. There will be a special test emulator with the less amount of Android operating system resources. For example, there won't be calendar or other kind of stuff to reduce the amount, reduce the size and improve the performance. There will be a possibility to define your emulators in the Gradle, so everyone in the team and the CI will be able to use the same configuration to reduce the flakiness. And nowadays, like a Gradle also use the same runner. So Android Studio use the same Gradle runner as you are using from Firebase Test Lab. That's also good news, because that will reduce the amount of this will reduce this sentence. It's failing on the CI but working on machine, because both of them will use the same configuration. And I'm going to release most of the solution I mentioned here and other solutions that we are using in the company with the explanation and probably with the use cases as a library. And I'm thinking about name as Mocha, because as you noticed that espresso is the main ingredient of any coffee, so you can make different coffees. You can put milk and water, and I am thinking that maybe they design it like that so we can write our layers on top of it and make it a different coffee. So thank you for listening. If you have questions, I'm not sure if I have time.